Welcome, an initiative by Kikewa College of Horticulture, Nasik, from Department of Soil Science. I, the Professor Ines Gogre, will going to deliver an audio-visual learning for students on topic remote sensing. Remote sensing of soils and plants. Application of remote sensing in study of plant, soil and plant. So what do I mean by remote sensing? Remote sensing is also used for land surveys, including mapping of soil, physical properties, soil types, fertility, toxicity, moisture content, and erosion, and for irrigation requirements, water quality, water availability, and plant drought stress is called as a remote sensing. Means it is used to study soil fertility status and plant nutrient availability status, and also some water quality features. So what are the different applications of remote sensing in agriculture in relation to soil and plant? It gives the soil moisture data and helps in determining the quality of moisture in the soil, and hence the type of crop that can be grown in the soil is easily determined. Through remote sensing, farmers can help sorry through remote sensing farmers can tell where water resources are available for a use over a given land, and whether the resources are adequate for the purpose of growing plants. Then it is a process of acquiring information about the Earth's surface by measuring its reflected and emitted radiation without coming into direct contact with object. In much of remote sensing, the process involves an interaction between incident radiation and targets of interest that is easily depicted in the figure. The most useful electromagnetic radiation in the remote sensing used are includes visible light, that is VIS, near infrared, that is NIR, and short wave infrared, that is SWIR, to the thermal infrared TIR, and microwave bands. Then in the passive remote sensing, sensors record incident radiation reflected or emitted from the objects, while active sensors emit their own radiation which interacts with the target to be investigated and returns to the measuring instrument as shown in the figure. Remote sensing, that is collecting information primarily by sensing radiation that is naturally emitted or reflected by Earth's surface or from the atmospheres, or by sensing signals transmitted from a device and reflected back to it, as it is depicted in figure that is shown earlier. Then remote sensing processes components: energy source or illumination, that is A, then radiation and atmosphere, that is B, interaction with the target, that is C, then recording of energy by the sensor, that is D, transmission, reception and processing, that is E, and interpretation and analysis F, and finally application G. Then types of remote sensing, there it includes two types, that is passive remote sensing and active remote sensing. Then what do you mean by passive remote sensing? It makes the use of sensor that detected, reflected or emitted electromagnetic radiation, in bracket EMR, from natural sources. that is called as the passive remote sensing. Then let's study about active remote sensing. It makes use of sensors that detect reflected responses from objects that are irradiated from artificially generated energy sources such as radar, called as active remote sensing. Then platforms used for acquiring remote sensing data. Number one, aircraft, that is having low, medium, and high altitude. Then higher level of spatial detail. Then number two, that is satellite, that is polar orbiting, 800 to 900 kilometer altitude and 90 to 100 minutes per orbit. Then geosynchronous, 35,900 kilometer altitude and 25 hours per orbit. Stationary relative to Earth, that is a characteristic features of platforms used to acquire remote sensing data. The most important feature of remote sensing is GIS. What is GIS? That is an organized collection of computer hardware, software, and geographic data and personal designed to efficiently capture, store, update, manipulate, analyze, and display all forms of geographically referenced information. That is called as a GIS. It may be thought of as a high order maps called as a GIS, Geographic Information System. Then remote sensing in agriculture. It is carried out for crop yield modeling and estimation. In this, farmers and experts to predict the expected crop yield from a given formulated farmland by estimating the quality of the crop and the extent of farmland. This is then used to determine the overall expected yield of the crop. The next, that is identification of pest and disease infestation. Remote sensing technology analyzes and plays a significant role in identification of pests in farmland and gives data on the right pest control mechanism to get rid of pests and diseases on the farm. Then number three, that is estimation of soil moisture. Soil moisture can be difficult to measure without the help of remote sensing technology. In this, remote sensing gives the soil moisture data and help in determining the quality of moisture in soil and hence the type of crop that can be grown in the soil. Then soil mapping. Soil mapping is one of the most common yet most important uses of remote sensing. Though soil mapping, farmers are able to tell which soils are ideal for which crops and which soils require irrigation and which do not require irrigation. This information helps in precision agriculture farming. Then monitoring of droughts. The remote sensing technology is used to monitor the weather pattern of given area. The technology also monitors drought patterns of the area too. The information can be used to predict the rainfall patterns of an area and also tell the time difference between the current rainfall and next rainfall with the help of to keep track of the drought. Then water resource mapping. It also useful instrumentally in the mapping of water resources that can be used for agriculture over a given farmland. Though the remote sensing farmers can tell where water resources are available for use over a given land and whether the resources are adequate or not. It is all about remote sensing in agriculture. Thank you.